One of the most applications of L'Hopital rule is finding the limits of the form 1 to infinity, 0 to infinity, and infinity to 0. And so the key step to doing that is to write limit as x approaches c of whatever block that you have, and the form of limit of exponential of natural log of that block. Notice that e to the power natural log are going to be inverse of each other, so you haven't changed the limit at all. And so e to the natural log is kind of awkward to write, and we write it as exponential, exp of natural log. And then the beauty of the exponential is that you can actually take it outside the limit or bring the limit inside the exponential, because it's a continuous function. And so all of these equalities are allowed by the limit laws, because the continuity of exponentials, and so on and so forth. Now, so it's important to know that this technique changes the limits into one of the form 0 times infinity. So rather than having 1 to infinity, 0 to 0, or infinity to 0, we'll get the form 0 times infinity. And here a little bit of a sketch of how everything works. So if it's 1 to infinity, it becomes e to the power natural log of 1 to infinity. Infinity is the exponent, so it becomes exponential of infinity times natural log of 1, which is e to the power 0 times infinity. In here, 0 to 0 becomes natural log of e to the power natural log of 0 to 0. 0 comes down, natural log of 0. It's going to be again 0 times infinity. Infinity to 0, again the same story, and 0 comes down, and you get e to the power 0 to infinity. So that's the basically it's just we doing a little bit of calculation with the forms, but we're not calculating numbers here, we're just sort of calculating the forms. Now, example 6. Let's try to find the limit of x to the power x as x approaches 0 from the right side. So the discussion is that what I know is this is 0 to 0, so I have to convert it to become infinity, 0 times infinity, and then convert it to infinity over infinity, or 0 over 0. And so let's write down the limit, and then write down exponential of natural log of x to the power x. So we haven't changed anything, because exponential of natural log, they basically are inverse of each other. Now let's use our exponential laws. So it becomes exponential of x natural log of x. I can bring the limit in. Sorry. Limit comes in. Of x natural log of x. Now, x natural log of x is of the form 0 times infinity, and therefore what I need to do is to write it as infinity over infinity instead, by taking x to the bottom. So I get exponential limit x goes to 0 of natural log of x over 1 over x. And then I do a L'Hopital rule. After L'Hopital rule, again, don't forget the exponential, don't forget the limit. I get 1 over x over negative 1 over x squared. If I simplify it this time, it's limit x goes to 0, positive side, negative x. And as x goes to 0 from positive side, this is going to be, and the entire thing is going to be going to 0, so it's going to be e to the power 0, and that is 1. Now let's do a limit that is infinity to power 0. This time around, I know that as usual I'm supposed to do limit x goes to 0 from right side, exponential of natural log of whatever I have in here, and then by doing that, basically the exponent will come down, and so limit as x approaches 0 from positive side, exponential, x comes down, natural log of negative natural log of x. And now if I plug in 0, I get 0. Plug in 0 in here, I get negative infinity. Negative times negative infinity, natural log of infinity, which is positive infinity. It's 0 times infinity. And so now I should do something to make it into L'Hopital rule by taking x to the bottom. Limit x goes to 0 positive, exponential, natural log of negative ln of x over 1 over x. Now I can bring the limit in, exponential limit x goes to 0 from positive, natural log of negative natural log of x over 1 over x. This is infinity over infinity. It's time to do a L'Hopital rule, and we end up with 1 over, let's see, limit is forgotten. Let's write it. Limit x without the limit is not correct. 1 over negative natural log of x times derivative of inside, which is negative 1 over x, divided by 1 over x squared. Now, after simplifying, because I don't want to do another L'Hopital rule with a lot of functions sitting there, and so I simplify it one more time, and what I end up with is x over natural log of x. As x approaches 0, oh, there is something missing. Exponential is missing. As x approaches 0, ln of x is going to approach negative infinity, and so it would be 0 over infinity. This is not an indeterminate form, and this is going to end up with being equal to 0, and so it's again exponential of 0 equal to 1. Example 8. This time let a be any real number, so that let limit of as x approaches 0 of 1 plus ax to power 1 over x has the indeterminate form 1 to infinity. So how do I deal with this? This is going to, we're going to do the same routine with any of those 1 to infinity, infinity to 0, 0 to 0. What I do is I write down limits as x approaches 0, exponential, natural log of 1 plus ax to power 1 over x. And I can even bring the limit in as soon as I see it. Limit, and then simplify the natural log. It's 1 over natural log of 1 plus ax. And then now I have a natural log of 1 is going to be 0, 1 over x is going to be infinity. This one is a little easier because writing it as 0 over 0 is very natural. And I get natural log of 1 plus ax over x. And this one, this time around, it's 0 over 0. So it ends up with exponential. Then I do L'Hopital rule and exponential of L'Hopital rule. This log becomes 1 over 1 plus ax times derivative of inside, which is a. Derivative of bottom is 1. And I forgot the limits, and never forget the limits, because otherwise this entire thing is becoming untrue. So limit x goes to 0. And if I plug in 0, what do I end up with is exponential of basically 1 and times a divided by 1, and that's a. So it's going to be e to the power a, and that's the limit.